So graphing the square root function. So our general equation of the square root function is f of x equals a times the square root of x minus h plus k. So these follow the same general rules of all the other functions we've graphed so far this year. Can anybody remind me what the a will do to my graph? Anybody remind me what the a will do to my graph?
I got it. It's the thing that it's the variable that has the reflection of the x or y axis.
Okay, so it can be a reflection over the x or y axis. If so, it could reflect. Well, it's going to reflect over which one?
X.
Reflect over x if what?
It's negative.
If a is equal to -1. What else can the a do to my graph?
Is it horizontal or vertical? Vertical stretch or shape.
Okay, so it could be a vertical stretch if a is what?
Greater
Greater than 1, or a vertical shrink
between 0 and 1.
if a is between 0 and 1. So greater than less than 1 and greater than 0. So the a term is a reflection over the x axis if a is negative. It's a vertical stretch if a is greater than 1, and it's a vertical shrink if a is between 0 and 1, so any fraction, 1/2, 1/3, and so on. What will the h term do? So if I had x minus 2 or x plus 5, what will the...
Horizontal translation.
Yeah, perfect. It's a horizontal translation. So it's a horizontal shift or translation. I'm just going to put shift. It moves to the right if h is greater than 0. Left if h is less than 0. And last one here, what will my k value do to my function, assuming k is positive or k is negative?
A vertical shift.
Vertical shift, excellent. When is it a vertical shift up? When is it a vertical shift down?
It's up when it's positive.
Up when it's positive, perfect, when k is greater than 0. Down when k is less than 0. So let's look at our first equation. This is our parent graph. F of x equals the square root of x. We're going to graph this. I'm going to make myself a little table here to graph some x and y values. So I have my x and my f of x. Okay. What's the smallest value or value that I can plug in for x? Can I plug in any value for x for this function? So another word of rephrasing my question is, what is the domain of this function?
It's going to be greater than or equal to 0.
Yeah, so my smallest value here is 0. I can't plug in a value smaller than 0, because if I plug in a negative number, can I take the square root of a negative number and get a real number? No, I can get an imaginary number, but I want all real numbers. So the smallest value is 0. When I plug in 0, the equation is the square root of 0, so f of 0 is just 0. So my domain is x is greater than or equal to 0, or you can say from, in brackets, 0 to infinity, depending on your notation. All right, so I'm going to pick some easier values. So when x is 1, what is the square root of 1? 1. I'm going to skip 2, skip 3, go to 4, because what is the square root of 4? 2. So I'm trying to give myself some nice numbers to work with. And let's go one more. When x is 9, square root of x, square root of 9 is 3. So if I plug these numbers in, so 0, 0, I'm going to plug in here. Here's my 0, 0, 1, 1, 4, 2, and 9, 3. And then I'm going to draw my graph there. And the graph is going to be in a direction like so. So it doesn't grow very quickly. but it's in that format. Okay, and this is the positive square root of x graph. Okay. Okay, so here's another example. F of x equals the square root of x plus 1. Again, you could always use a table. I'm going to put back my parent graph that we just graphed in the last one. I'm going to put that back there. So there's my parent graph. And what does a square root of 1 plus 1 on the outside going to do to my function here?
Vertical translation up 1.
Excellent. It's going to be a vertical translation up 1 unit. So I'm going to put this graph in black. So I'm going to take this graph and I'm just going to move it up 1 unit up top. What is my domain of my parent function in red? What's the domain of this function? What did we say the domain of our parent function was?
X is greater than or equal to 0.
X is greater than or equal to 0. And what is my domain of my new function here? Square root of x plus 1. What is the domain of this function?
X is greater than or equal to 1.
X is greater than or equal to 0. Same function. Okay, so all I did, my domain is still the same amount of money, same amount. X is greater than or equal to 0. Okay, and now, so the domain is the same. So the plus 1 didn't change the domain of the function because the x values didn't change. Okay, they're still going from 0 and on. But does the range change? What's the range of my parent function? What's the range of my parent function?
Y is greater than or equal to 1.
Y is greater than or equal to, of my parent function, the parent function is going to be y is greater than or equal to, not 1, but
0.
0. The new function, the square root of x plus 1, what's the range of that one? What's the lowest this graph goes in that one?
Y is greater than or equal to 1.
Yeah, this one's y is greater than or equal to 1. So this plus 1 on the outside just changed the range of the function. Didn't change the domain because I'm still limited to only plugging in 0 as the smallest x value. Okay, our next function, f of x equals the square root of x minus 1, and the entire x minus 1 is inside the square root. Okay, so a little difference there. So what's the difference on this one? What kind of transformation would this be?
Horizontal translation 1 unit, right?
Yeah, this is going to be a horizontal transformation or shift right 1 unit. Okay, so my graph here, so my parent graph would start here, and if I'm shifting 1 unit to the right, I move it over here. What is my domain and range of this function now? What's the domain and range of this function now? The domain of the function will be what?
Greater than or equal to 1.
Okay, so now the domain of this function is going to be x is greater than or equal to 1. I can no longer use 0 because if I put 0 in here, I'm going to get 0 minus 1. And what will be my range of this function?
Greater than 0.
The range is going to be y is greater than or equal to 0. So keep in mind here, when you're looking for your domain, I'm really asking myself, this argument inside, x minus 1, when does that x minus 1 equal 0? Because that's the smallest value I can plug in there. So inside here, when x is equal to 1, this whole thing would equal 0. Well, if I can check, this is 1. If I check numbers to the right of 1 and numbers to the left of 1, can I plug in a number? So I'm allowed to equal 1 because this is going to be equal 0. Can I substitute in 0? Can I input 0 in for x? What's 0 minus 1? Negative 1, so I can't use this. What if I go to the right of 1? What's 2? It's 2 minus 1. So this side works, which is why I want my domain to be x is greater than or equal to 1. Okay, so here's the next function. F of x equals 2 times the square root of x. What will that 2 do to my function? So you have f of x equals 2 times the square root of x. The 2 will do what to my function? What kind of transformation?
A vertical stretch.
Yeah, this
by
is going
factor 2.
Excellent. This is going to be a vertical stretch by a factor of 2. So let's get back my original function, or my original graph here. Just going to put that here. And I'm going to use a table of values in this one just to see what happens to my function. So I'm going to plug in some values in for x. Again, the smallest value, or I can plug in for x here is what? What's my domain of this function? Okay, so x is greater than or equal to 0. So if I plug in 0, square root of 0 is 0. 0 times 2 is 0. So that doesn't change. Put that one here in green. I'm going to plug in 1. Square root of 1 is 1. 1 times 2 is 2. So when x is 1, y is now 2. I'm going to plug in another number. I'm going to plug in 4. Square root of 4 is 2. 2 times 2 is, so when x is 4, y is 4. And one more. I'm going to plug in 9. Square root of 9 is, and 3 times 2 is, and that brings it up here. So this is the function of, this is the square root function with a vertical stretch by a factor of 2. So this is your 2 radical x, and this is just your radical x. Alright, so let's look at another example. Okay, here's our next example. F of x equals the square root of 2 times x, and now the 2 is on the inside. So what kind of transformation would this be? What kind of transformation would the square root of 2x be?
Would a horizontal shrink
Okay, good. So it's going to be a horizontal.
by a factor of 2? Or
Horizontal shrink by a factor of, if it's a shrink, it's going to be by a factor of 1/2. Alright, so let's see what the difference is here. So let's plug in some values. Again, I'm going to plug in my 0 for x. 2 times 0 is 0, so y would be 0. I'm going to try to give myself some values for x that are going to give me some perfect square roots. So what can I what can I input for x that will give me a perfect square root? If I plug in 1, 2 times 1, is that going to give me a perfect square? No. 2 times 2. So I'm going to use 2 for x, which is 2 times 2, which is 4. The square root of 4 is 2. What else can I use?
8.
8 would also work. 2 times 8 is 16. Square root of 16 is 4. So I got 3 coordinates here. I'm going to use those to plot. So we got 0, 0. We got 2, 2. And we have 8, 4. 8, 4. And bring that down. And this is the graph of square root of 2x. And this is our horizontal shrink.